Hello, good morning minions. Welcome aboard. This is Shreyas here, your master teacher for physics at Vedantu, going live for this Zero to Hero series. And today's topic is optics. So welcome aboard all the JEE 2021, JEE 2022 aspirants. Welcome. I know you guys are preparing really hard for the upcoming April examination. So all the 2021 aspirants, this Zero to Hero series is aimed exactly for the April attempt or for any other entrance test that you might be writing this year. These are one-shot videos, alright, designed, curated by all of us so that you can grasp all the concepts, revise all the concepts of those topics and also apply those concepts in different problems. So welcome aboard. I am Shreyas, and over the last 1 decade I have been responsible for producing lots and lots of ranks, and lots of students, hundreds of students have entered IITs, NITs, BITS and you name it, thanks to the guidance given by me, and I'm really proud of this fact. And guys, if you want to know more about me, you can definitely follow me on my Instagram handle Shreyas_Vedantu. You can also ping me out there and I will try and respond to all the queries. And before we begin today's session, do not forget to hit the like button to show us your love and support. And please share these videos, our channel name, with your friends. Recommend this channel to your friends and all your batchmates who would be interested to study with all of us. And yes, if you are new to this channel, do not forget to hit the subscribe button down there because it's free of cost. Make that red button go white. Hello Shri Krishna. Hello. Wow. It's nice to, start your day with God's name and all that. Wow, nice to have Sri Krishna so that you can start your day with taking his name. Hi Nancy, hi Alni, hi Snehal, hi Shruti, hello Fatima, hi Shreyas, hi Reenu, hi Gayatri, hello Snehal, Shruti, welcome Crazy Aman, welcome Anushri. Oh my god, Anushri, you're from class 10th and you're free. Well Anushri, let me tell you, for you and all your batchmates, we are coming up with something really special. In fact, that's tomorrow and on a regular basis very soon for all the class 10th to class 11th moving students as well. Yes, yes Daniel, you can use this channel for NEET exam. I think I have told you about this before also. Yes, you can definitely use all the videos, all the lectures for NEET as well, because guys, physics is physics at the end of the day. Good morning Chivas CH Yuvashri, welcome. Good morning Jaya Murugan Education. Good morning Yalini. Good morning everyone out there. All right, so let's see the schedule. Guys, there is also Pathfinder series which we have just launched. Yesterday was the first class, like you can see. So what is Pathfinder? It's a long-term batch on YouTube. Just like you have your regular coaching, we have decided to teach you all the topics of 12th standard. Now the first topic obviously in physics is electrostatics. Then we'll go to Gauss law, current, electricity, magnetism, modern physics, everything, AC, everything will be done. Same thing in maths and chemistry. So tonight we are going to see at 9 o'clock forces and field. So do not forget to join us live at 9 o'clock tonight. Okay, that's one thing. Then also, like I said, Zero to Hero series is all for 2021 aspirants. Even if you're 2022 or 2023 aspirant, it's okay, you can still join in. So we are going to have this and remember guys, one more thing, that some of the lectures are already done, so you can check out the playlist in Zero to Hero series and you can cover up all your backlogs. All right, so if you have missed any of these classes, you can cover up, but you can see ahead we have planned a lot of sessions for all of you. All the topics of 11th as well as 12th are going to be completed. Yes, thank you Yalini. And guys, do you see this special thing? I don't know, some of you did not notice. Well, there is a special thing lined up for all the 10th to 11th moving students in case you missed it up. All right, so that's what we are going to see tomorrow. All right, and Killer 5 for JEE Advanced preparation. Yes, for all the students who are preparing for JEE Advanced, guys, we have started Killer 5 series, 5 tricky, conceptual, very good questions on every Saturday in physics and similarly in maths and chemistry. So this Saturday, Killer 5 in kinematics. So do not forget to check that out. All right, so let's begin our class. Just 1 second, guys. Let me see. I think my screen is little bit blurred. Okay, yeah, now I think it should be a little bit fine. All right, so also do not forget to check out the vote details, which is Vedantu Online Talent Examination, because the next examination is on 11th of April and the next one is on 18th of April. In case you have missed the previous 2 dates, please check out the link which is there in the description box below. There's lots of prizes to be won, chance to become a Vedantu CEO, also get a chance to go to NASA as well. So lots of exciting gifts, lots of scholarships. So please do not forget to check out the vote details. So let's begin. Now, Daniel, like I said yesterday also, like as soon as Wazim sir is fine, he will start the chemistry series as well. Okay, so Anushri for sure would have noticed it because she's from 10th standard. All right, okay, cool. Ankit, oh my god, yeah, that's what I was wondering. Ankit, you were not there yesterday because usually you come up with those hearts. I hope, Ankit, you are well and you become a little bit better. All right, so don't worry. Let's forget that you have fever and let's concentrate on the class. Try to focus, relax, and guys, please take care because of the situation that is going around you. So make sure that you are healthy and you are fit and you exercise every day, drink hot water even though it's summer, and yeah, please take care of your health and maintain social distancing. Hello Vignesh, Sridhar, welcome. Good morning Praveen, good morning, good morning. So let's begin. Now first thing that I want to tell you is all the important formulas that you should know. First of all, laws of reflection. Angle of incidence is equal to angle of reflection. Incident, reflected and normal ray lie in the same plane. They are all in the same plane. That's number one. Okay. Now, the next one, remember the different properties of an image when you see it inside a plane mirror. Image distance is same as object distance, meaning as far as you are away from the mirror, the image is also as deep inside. The image height, object height is the same. That means there is no magnification like when you see in the mirror. The image is virtual. Also, remember the image is erect. So it's not like you stand there and you see an upside down image of you. No, the image is erect. And also some more formulas relating to mirrors. Remember the angle of deviation is 180 minus 2i. In case you have forgotten that, that's the angle of deviation. So if a ray touches the mirror and deflects, the total deflection, the total deviation is 180 minus 2i. Keep this in mind. Hi baby Luffy. Hi Shrikar. Hello Ravan Varun. Oh my god, Ravan Varun. Alright. Good morning Chandrasekhar. Hello Karthike Reddy. Good morning guys. Welcome. Join into the session. We have just started the Zero to Hero series for optics. Welcome aboard. Okay. And remember that we have also or rather you should remember a few more things like the minimum size of the mirror to see oneself. So if let's say there is a Pandu over here and he wants to see himself in the mirror, understand the minimum size should always be the height by 2. Keep all these things in mind. Next, spherical mirrors, curved mirrors. So whenever you have a curved mirror, first of all, there is something like the radius of curvature. The radius of curvature is that radius of the circle which the mirror is a part of. Remember, so if you extend that mirror, it becomes a sphere. The radius of the sphere is the radius of curvature. So f is r by 2. That's first formula. Mirror formula is 1 by v plus 1 by u is 1 by f. Magnification is minus v by u. This magnification minus v by u is this kind of magnification, the magnification which is perpendicular to the principal axis. So height wise magnification. But if you want to talk about the magnification width wise, that's remember minus v square by u square. That's the formula. And the formula for power is negative 1 by f. Keep this in mind. The power of a mirror is negative 1 by f. Keep this in mind. Hi Somit. Good morning. Yes KP, that's Pandu. Looks like you were there in many of the classes before. Hi Soham Bhattacharya. Hi Deepika. Good morning everyone. Welcome to the Zero to Hero series. So guys, if you are preparing for the April attempt, this series is must for you. And if you are preparing for 2022 or 2023, it's okay. You can still attend. And remember, you can always gain knowledge and you can solve questions, which I'm going to start in a bit. Okay. So let's start with some questions. Like I just said, here it is. There are two statements. First statement is the formula connecting image distance, object distance. So U is object distance, V is image distance. For a mirror which is curved, that is spherical mirror, alright, it is valid for mirrors whose sizes are very small compared to the radii of curvature. So that 1 by V plus 1 by U is equal to 1 by F is valid only for mirrors with small radius of curvature. That's statement 1. Statement 2 is the laws of reflection are strictly valid for plane surfaces but not for large spherical surfaces. They are not valid for large spherical surfaces. They are only valid for plane surfaces. What do you think? Are both of them correct? Is one of them correct, one of them wrong? And if both of them are correct, is the second statement the correct explanation of the first statement? What do you guys think about it? Hello Vijay Lakshmi, good morning. Yes. Okay. Come on. Good one, Shreyas out there. Alright, come on minions. What do you guys see? Think it's C. Alright. Some of you are saying it's C. Okay, Snehal says C. I don't know. Let's figure it out. What do you guys say? Good morning, Harni Avantika. Good morning. Thank you for all the love. Good morning. Join in. We have started just with the first question. I just discussed the theory of mirrors and reflection. Alright. So guys, we are going to discuss all the theory. Remember, refraction, apparent depth, all these things are going to be discussed today, including prisms. So it's a one-shot lecture. Sriniti says C. Alright, Shreyas says D. Yalini says C. Gayatri says C. Sri Krishna says C. Alright, interesting. Alright, so guys, guess what? The answer, I'll tell you what. Now, before I show you the answer, good morning Vikram Nirmal. Remember that laws of reflection, alright, laws of reflection, understand, is valid for every part of a curved mirror. And this law which is there, like say for example you have a ray which is coming in and it hits a plane mirror, then it will reflect back like this, assuming this is angle of incidence, then this will be angle of reflection. Now even if the mirror is curved, you can think it is made up of small plane mirrors. Think that a curved mirror is made of small plane mirrors. So every point the law of reflection must be obeyed. So even if it's a curved mirror, it's made of small plane mirrors. I hope this is clear. Definitely Sonali Shivade, definitely I'll try and reply on Instagram. Don't worry. Yes. So let's concentrate on the class. For sure I'll reply. Don't worry. There is a lot of backlog on Instagram. I know I have to respond to a lot of queries. I will do that. Hold on. Okay. Now, that's why second statement is wrong. Laws of reflection are strictly valid for plane surfaces but not for spherical surfaces. No, this is not correct. It's valid for spherical curved surfaces as well. Good morning, Nirmal. Now, the first statement says the formula connecting those distances and focal length is only valid for mirrors which are very small compared to the radii of curvature. Now, that is very true. Remember, when you have a big mirror, remember, if rays go parallelly, ideally they should meet at the focus, correct? If rays are incident parallelly, they should meet at the focus or at least appear to diverge from the focus for a convex mirror. But remember one thing, the rays which are very far away from the principal axis do not actually meet at the focus. Like you can see over here, they are slightly little bit off track from the focus. Now larger the mirror, the larger is the distance between the different focal points. So understand, only when the mirror sizes are small, you will see the rays which are parallel exactly meet at the focus, but as you start going away, you will see all those rays will not exactly meet at focus, they'll meet at different points. This kind of error is called something. What is this error called? It's there in NCERT, guys. What is this error? Because all the rays do not meet exactly at the same point, so the focal point is not the same, so because of which there is some defect which is produced. What is that error called? Come on, think about it. Nirmal, I think the schools will be online these days, and try to watch as much as you can live, and whatever you cannot watch live, please watch it recorded. So guys, there is a name for that, and that is spherical aberration. What is the name? Spherical aberration. That name will also be there in your NCERT books. Please check it out. Spherical aberration. That means that there is an error produced in the image because the focal point is different for different rays. Yes, it's not parallax error. Okay, so keep this in mind. Okay, so statement 2 is wrong. Statement 1 is correct. As simple as that. That's why C is the correct answer. Keep this in mind. All right, let's move ahead with the next question coming up on your screen. So I hope you have learned a lot from this question. So we have talked about spherical aberration. Spherical aberration is basically that property where the image becomes blurred or the image is not crisp because of different focal points. Second thing, the radius of curve, the size of the mirror should be small to get a crisp, clear image. And also remember that the laws of reflection are not just valid for plane mirrors but also for spherical mirrors, because every point on the spherical mirror is a plane mirror. Keep this in mind. Very good, very good. So what is chromatic aberration? Chromatic aberration is basically the error which is produced because of different colors. Now for mirrors, that's not a problem because yellow color, red color, violet color will reflect the same way. But in lenses, they will refract differently. So if you take a convex lens, understand, usually whatever rays are parallel should meet at the focus. But yellow light, red light, violet light, blue light, green light all have different refractive indices. You know that through prisms. So because of which the rays won't meet at the same point, there will be a separation between all the colors. That error which is produced is called as a chromatic aberration. Okay, cool. Let's get going. So I hope I have answered all your doubts. Good morning, Satyendra Kumar Singh. Very good, baby. And baby is also here. Yes. JEE Enthuse, baby. All right. Very good. Let's get going to the next one. Good morning, Jayavardhan07. Welcome. Good morning. An object is placed at a distance equal to the focal length. Distance equal to the focal length. But in front of a convex mirror. The mirror is convex. If the focal length of the mirror is f, then the distance of the image from the pole of the mirror is, then what is the distance? Come on, think. All right, Vishal. So at least 2 days, maybe you will have to change your yoga time to before 7 or after 8:30. Okay. So hello Naveen Reddy, welcome. Okay, Meghna says A. I don't know. Let's figure it out. Come on, minions. Think. Come on, minions. Come on, everyone. Come on. Priya says A. Somit says A. Meghna says A. Snehal says A. ABCD says A. Ankit says C. Vishwa says D. Interesting. I'll tell you what. The actual answer is less than F. And I'll tell you why this is true. Guys, use mirror formula. That's it. So 1 by V plus 1 by U is equal to 1 by F. That's the mirror formula. Now I don't know where the image is, but the U value, the object is at a distance of the focal length, but it's on the negative side, so minus F. Remember, this is the positive side, this is the negative side, because the rays of light are going like this. So keep this in mind. Always the pole, alright, that pole is always the origin. This is always the origin. And wherever the rays go, that's the positive side, if the rays are going like that. So whatever is there on the right side of the pole in this situation is positive, left side is negative. So object distance is negative and this is 1 by F. So therefore 1 by V is equal to, shift this guy over there, it's going to become 2 by F. 1 by F plus 1 by F is 2 by F. And therefore V is F divided by 2, which is definitely going to be less than F. I hope this is clear. Excellent. Isniel got +4. Very good. Excellent. A lot of minions got this correct. Very good, minions. Very good. Very good. Let's get going to the next question. Now this is really interesting. Let's see if you can derive this very quickly. I'll give you 1 minute. 1 minute to do this. This is actually a 1 minute question, and these kind of questions can come in JEE Mains, NEET and BITSAT. in a concave mirror, an object is placed at a distance of d1 from f, from focal point. Be careful. And d1 is not the object distance, d1 is the distance from the focal point. And the image is formed at distance d2 from the focus again. It's not measured from the pole, so be careful. Then what is the focal length of the mirror? Come on, do this. Okay. So Vishwa, the ray diagrams, oh yes, I have in fact given all the ray diagrams as a PDF, alright, to all the students. If you check out, there is a playlist called Optics in Flash series. Alright, there is a separate playlist for optics, and in that playlist there are ray diagrams which are given in the session PDF. Just check out the description box, or if you are on Telegram, you can just scroll up to those dates and you can find it. So both the options are there. Yes. Come on. So even for previous question, even if you want to draw the ray diagram, well, it is not going to be difficult. So this is for the previous question, by the way. So it's going to look something like this. This is going to look like this, and you're going to see, one of the ray which will be parallel, it will go away from it, and if you extend it, it will go like that. And another ray, you can just say, let's say for example, it goes like this, it gets reflected back, and it will be here. So you can see this is where the image is. This is where the image is. I hope this is clear. Okay, that's how it's going to look like. Morning classes, how? Because morning classes are fun and you guys should wake up in the morning, because if you want to improve your memory, if you're committed for JEE, guys, understand morning classes are not mandatory. Only if you're committed for JEE, and if you're committed for NEET, if you're committed for bedside, if you want a good college, guys, you should wake up in the morning and study in the morning and not study late in the night, because it will deteriorate your brain, it will deteriorate your health. And there was a recent study which was published that late night work or studies or anything else is going to be riskier for your heart, for your brain, and can cause strokes and a lot of diseases later on in your life. Also, waking up in the morning keeps you fresh, makes the day feel longer. Also, your mind is active, and in fact, you will have a very quiet, silent environment to study for. Yes, full of energy. Very good, Sheetal. Excellent. Okay, thank you, Sheetal, for all the love. Yes, cool. A lot of you are saying B. Well, I'll tell you how to do this problem. Start with mirror formula. So 1 by V plus 1 by U is equal to 1 by F. Correct? Now, what is V? Image distance. But image distance has to be from the pole. Now, the image is formed at distance d2. Alright, the image is formed at a distance d2 from the focus. So be careful. From the focus, the image is d2. So from the pole, it will be d2 plus f. It will be d2 plus f. I hope this is clear. This will be d2 plus f because it's measured from the pole. d2 is from the focus plus the focal length. But do not forget the sign convention. There will be a minus sign over there. That minus sign is because it's on the left side. Remember, this is negative, this is positive, and so on and so forth. Similarly, the object distance. Remember, the object is at a distance of d1. This is given from the focus again. So again, it will be d1 plus f, but it will be negative sign because it's on the left side. And this is a concave mirror. So this will be again, let's say minus f. I just assume the mirror to be concave. All right, it's given in the question. Now that minus goes, correct? The minus goes, and take LCM. So when you take LCM, on the top over here you will have d1 plus f. On the top over here you will have d2 plus f, and below you're going to have the product of the two. All right, and that's going to be d2 plus f into d1 plus f, and here you have 1 by f. Now cross multiply. Now first of all, look at this. F plus f is 2f, and f into all these terms is going to give me, think about it, d1f plus 2f square, because f plus f is 2f. 2f into f is f square plus d2f. Correct? That's what I'm going to get. And over here, I'm going to get again a lot of terms. You can see that. So one term will be D1 into F, D1 into F. Another term will be D2 into F. Another term will be F into F, which will be F square. And the last term will be D1, D2. Okay, that is D1, D2. Now check which all terms get cancelled. Okay, D1F, D1F, D2F, D2F, F square, 2F square cancels, only one of the F square is remaining. So guys, can you see that F square on the left hand side is actually equal to D1, D2. So F will be root of D1, D2, root of D1, D2, be careful. Okay, I hope now it is clear. Hello Chaitra Reddy, no problem. You missed few questions, but you can always replay it back later on. Alright, for now just concentrate on the live class. So that's the answer guys, option A. Beautiful question. In fact, yes, all the terms except D1, D2 got cancelled. Yes, beautiful question. Option A was correct. A lot of you got wrong, some of you got it correct. Okay, no problem. But now you understood, and these kind of questions are common. In fact, there have been instances in JEE, in BitSat, all the distances were given from the focal point. People did not read the question and they solved it using mirror formula. Then they realized, oh man, what a mistake I did. So understand, this is in fact a formula. This is also called as Newton's formula. It's there in some of the books. This is called as Newton's formula. When you measure all the distances from focal point and not the pole. This is a formula trick, shortcut trick to save you a lot of time, and it will save you 2-3 minutes at least in the examination. Let's go to refraction. Good morning Aswani Babu, good morning. Yes, come on, let's get going. Very good Shreyas, it's clear. Very good Ankit. Hello, yes, very good Chetra. Okay, so let's get going. Refractive index, everybody knows this. It's speed of light in vacuum upon speed of light in a medium, which is C by V. It is also nothing but mu2 by mu1, which is sin I by sin R. Remember, mu2 by mu1 is nothing but 1 mu2, standard formula. So the ray actually goes from medium number 1 to medium number 2. Keep this in mind. So the ray goes from medium 1 to medium 2. It is called as mu21. 1 mu2, and it is pronounced as refractive index of 2 with respect to 1. Okay, so 1 mu2 is mu2 by mu1. You should know this formula, keep this in mind. Okay, and refractive index is also the speed of light in one medium upon speed of light in the other medium. Keep this in mind. Okay, so Porshi Kumar's wave optics is also going to come. In case you have missed the starting part of the lecture, watch the schedule which I have given. In the schedule, the wave optics details also have been mentioned when it will be conducted. Okay, so don't spam out here Shiva Kumar. You can put it once, don't put it 2 or 3 times, else the admin will block you. Okay, be careful. Okay, now getting ahead, critical angle. Critical angle is that angle for which, you know, the ray of refraction will come out almost parallel. Any angle more than that, the critical angle, the ray will get totally internally reflected. So it will get totally internally reflected, and if the angle of incidence from the denser medium is less than the critical angle, then it's going to exit out. It is going to refract, but with a different angle. So that is the critical angle formula. Critical angle is sine inverse of 1 by mu. Remember this. Okay, so that's how it is. Aishwarya, no, both wave optics and ray optics are covered in this lecture. No, today is only ray optics. Wave optics has a separate lecture. Alright, I don't want to mix the two. It cannot be done in 1.5 hours. So that's why I kept a separate lecture in the 0 to hero series, if you see the timetable carefully. Okay, that's another formula. Then refraction at one single curved surface. Yes, single curved surface. Keep this in mind whenever you see a tabletop. Have you seen those paperweights? Those are curved. Or you would have seen in a museum, they keep some species like a mosquito or an insect or an ant or something like that in those covered jars, or they keep it inside, or they are preserved as a fossil inside translucent material. And sometimes you would have also seen a dust particle or something which is there inside a glass container, all right, something like this. Let's say this is glass and this is curved. You see something inside. This is a curved surface. Whatever is there inside appears to be a little bit weird at a different place, magnified, diminished, etc. So that is single surface curved refraction, and the formula for that is mu2 by v, refractive index of second medium, upon image distance, minus mu1 by u, refractive index of the first medium, by object distance, is equal to refractive index subtraction, the difference of the refractive index, upon the radius of curvature. This is very, very important formula. Next up, magnification. So for this curved surface, usually magnification was v by u minus v by u. So same things are there, v by u, except that there is refractive index over here. So you have mu1 by mu2. Keep this in mind, mu1 by mu2. So mu1 by mu2, v by u. In fact, you can remember this like this. See, with v, you have mu2. With u, you have mu1. But in the magnification formula, understand, with v, you have mu1, this one. And with u, you have mu2, which is this one over here. So that's how you are supposed to remember it. Keep this in mind. Yes. Amber, yes. Amber glasses, correct. Very good. Lemon in a glass, very good. Looks like, yeah, you guys know a lot of, yeah, who keeps mosquito in a museum? My God, they do that. Guys, you don't know what kind of weird stuff you get in a museum. Trust me on that. I have visited so many museums in so many countries, and I have seen all kinds of weird things in a museum. So don't even ask about it. And what was the weirdest thing you saw in a museum? Please post it up in the comment section below. Okay, lens maker formula 1 by f. Now this is not for single surface, this is for a double surface. If you have two curved surfaces, it becomes a lens, and the lens formula is 1 by f is mu minus 1, refractive index minus 1, 1 by r1 minus 1 by r2. What is r1, r2? So if you have, if this is the lens, all right, each curved surface, so this is curved surface, this will have some radius of curvature r1, and the other surface will have other radius of curvature r2. So that is what you're going to put over here, 1 by r1 minus 1 by r2. Yes. So mystical Malayali, can you get 98 percentile in 1 month time if you have got 65 percentile? Well, it's difficult, but you can try. There is no harm in trying. Even if, remember one thing, even if you know that you're going to lose, or even if you're not getting something, there is no harm, and in fact you should try. Remember this in life, not just in JEE, in everything. Even if you know you're going to lose, you should try. If you give up, guys, you never know. You will always regret that you have not tried. Maybe just because you tried for 98, maybe there is a chance you might get 95 or 96 or 94. I don't know. So understand, don't give up. Okay. So let's get going. All right, to the next one. Lens formula. Instead of 1 by v plus 1 by u is equal to 1 by f, which is there in mirrors, you have 1 by v minus 1 by u is equal to 1 by f. Remember, in mirrors, magnification was minus v by u, but in lenses, it is plus v by u. Keep this in mind. And in mirrors, the power formula was negative 1 by f. In lenses, it is plus 1 by f. Keep this in mind. Yes, I'll be talking about apparent depth in a bit. Snehal, for 90 to 70, yes, that's very likely, that's very much possible. Okay, so Chaitra has not yet seen the weirdest thing in the museums yet. So don't worry, Chaitra, soon you will probably travel a lot. And once you go to IITs and once you go to NITs, guys, you get paid internships. You can travel around and they pay you for that. And a lot of people go to different countries, different cities, different places. They spend 1 or 2 months over there learning a lot from that industry or that institute, and at the same time you also travel a lot and you're going to make a lot of friends. It's amazing, and all of this will happen only if you go to the top-notch colleges, guys. It will not happen in a regular college. If you go to a regular college, probably you're going to do an internship somewhere, I don't know, in a brick factory around the neighborhood. But if you want, to go to cool places, if you want to explore life, guys, IITs, NITs, BITs, that's it. That's where you have to be. Yes. Okay. So last one. Okay. Now this was not needed actually. This is when the distance is separated, but don't worry guys, do not remember this formula, my bad. Okay. So if you have one or two lenses in contact, all right, then understand what adds is their power, P1 plus P2 plus P3, and power, remember, is 1 by F. So 1 by F1 plus 1 by F2 plus 1 by F3 will be 1 by F effective. That's what you need to add. Okay, so keep this in mind. All right, cool. So having said that, let's go to a problem. Total internal reflection can take place in which of the following 4 situations? Think about it. I also got paid internship to Goa and I'm a JEE Aspirant. Very good, Vishal. Looks like your school is really good, or whichever college you are in. Very good. Okay. So please make videos on how to study abroad in universities like MIT. Yeah, fine. We'll definitely consider that. Mystic Malayali. But there are very few people who go abroad actually. There is hardly a percentage. I mean, you need a lot of money to go abroad, number one. It's said that the education that you get in our country at graduation level, it's quite higher than what foreign universities impart you. Yes, the hands-on experience is obviously good in some of the foreign universities, but the level of mathematics, the level of depth you go in the graduation courses in most of the top colleges is really good. All right, a lot of you are saying option A, very good, and that is correct. When a ray moves from denser to rarer medium and the angle of incidence is greater than the critical angle. Very true, guys. So if you have a medium and if your angle is more than the critical angle, it will totally internally reflect. And remember, if the angle of incidence is small, it's going to come out, and exactly at the critical angle, it's going to almost be 90 degrees. So this is that critical angle. Keep this in mind. This is that critical angle. Less than the critical angle, it's definitely going to come out. More than the critical angle is going to reflect back. And remember, this is always dense medium and this is always the rare medium because the rays are bending away from the normal. So that's why the option is A. Going to the next question. A biconvex lens of focal length f forms a circular image of radius r in the focal plane. Then which of the option is true? Come on, let's do this. And guys, understand, at NITs and IITs and triple IITs, you don't have to pay too much. You get a lot of scholarships. Plus, the fees are quite less if you compare to a private college. If you compare it to the private college, like I remember I did my engineering from NIT and I hardly spent, I remember, close to 1 lakh or a little bit more for entire 4 years. Entire 4 years. Yes, Mystic Malayali, with 100% scholarship, it might not be expensive, but you need to be really, really extraordinary for getting that 100% scholarship. Let me tell you that. A very rare chance that people get 100% scholarship. Yes. So that's one important thing. And guys, how about studying in India or even studying abroad? It's okay, but working for India. Let's make in India, guys. Let's do stuff in India, guys. Understand, if all of us are going to go out and none of us are going to be in India, then understand there would be no Vedantu, there would be no Flipkart, there would be no Redbus, there would be no Cred and so many other companies, Dream 11 and so many other companies. So there were great minds who thought that we should do something for our country and they stayed back, and that's what is happening. Else, if everybody goes, then there will be nothing left. There will be only dirt left out here. Understand that. Yes, triple IT is very good, baby Luffy. Yes. Oh, no, no. Well, Snehal, you have seen a lot of IITians and NITians. That's because for teaching, for entrance exams, for IITs and NITs, you need somebody who has gone through the process. You cannot have somebody who has not been through the process and teach for IIT and NIT. So that's why you will see a lot of teachers out there who are IITians and NITians themselves and not B.Eds. All right. But remember, a lot of IITians and NITians are also involved in a lot of startups, a lot of companies, a lot of foundations, a lot of things which are going around the world. Yes, very good, Yalini. That's very true. Okay, thank you, Rohan. Okay, well, let's see what's the answer for this question. Now, the thing is, what you should do, imagine a lens like this, okay, and the rays are going to merge and the image is going to form at the focal point. So remember, one of the rule for the ray diagram says a ray which passes through the pole goes undeviated in case of a lens. So ray which goes through the pole goes undeviated. And I know that the image is going to be formed at the focal point. All right. So forms a circular image in the focal plane. It's given. The image is formed in the focal plane. So this is the focal point. So now think about it. Okay, if this is the focal point, this is the radius of that image, and this is the focal length. This is the focal length. This is the value of r, and this is theta. So think about it. Tan theta will be r by f. Tan theta will be r by f. Isn't that true? Now, just rearrange this. So you are going to get, oops. So this is tan theta is r by f. Okay, so f will be directly proportional to r. I hope you see that. F will be directly proportional to r because tan theta is a constant value. All right. Now, if f is proportional to r, f square is also proportional to r square. Correct? The focal length square is also proportional to r square. And then you can always multiply by a constant. It won't harm it. Alright, multiplying by a constant, it is still going to be proportional. So f square is also proportional to pi r square. Hence, this option is correct. I hope this is clear. Glad you said that, Snehal. Very good, Vishal. I like that thought. Very good, Nancy. Very good. Very good. Yes, Google CEO is an IITian. No. I don't think so. Sundar Pichai is not. Yeah, I don't think he's an. Oh yes. What the hell? It was Satya Nadella who is not an IITian. My bad. Satya Nadella is from MIT. Sundar Pichai is from IIT Madras. Very true. Yes. Okay. I always get confused between the two great personalities, Satya Nadella and Sundar Pichai. Yes. Okay. So let's get going to the next one. All right. Which of the following is true for rays coming from infinity? Come on. Let's see how many of you can do this. Which of the following is true for rays coming from infinity? Now, this is a special lens. The upper part is mu1, different medium. The lower part is different refractive index mu2. So think about it. Yes. Come on. Think. Which of the following is true? Will you get one image? Will you get two images? Or none of the above? Come on, think about it. No problem, Sriniti, and you can watch the replay of the remaining part later on. Do not forget to do that, guys. In case you are joining in late, it's okay. You can still continue watching the lecture, and you can watch the missed part later on. And yeah, make sure you do that. Yes, very true, Vishal. Oh my God, Jaya Murugan, 1 year. It is definitely possible to crack JEE in 1 year. I'll give you hundreds of examples where my students have cracked JEE in even 1 year, but you need a lot of hard work because those people who are studying for 2 years, they are not fools. So if you want to crack JEE in 1 year, you need 2x effort. So that's possible. Okay. Hello, Pravanjan Swani. Okay. And the correct answer is actually 2 images are formed. The reason for that is, understand, the rays which are parallel over here, they will meet at one point that will have one focal length. The rays which will travel from here, they will meet at some other point which will have some other focal length. So if there are two focal lengths, f1 and f2, so understand, so when I use this relationship 1 by v minus 1 by u is equal to 1 by f, for each f there will be a different image. So because there are two focal lengths, there will be also two images for the same object distance. Object distance is only one, but there are two focal lengths, so there are two images. Hence, two images are formed. I hope this makes sense. I hope this is clear. Very good. NIT Uttarakhand, is it a good college? Well, it is definitely not the top NITs, but it is a decent, normal, average NIT. Okay, Shreyas Kapri? Okay, very good. Ananda Paraba, if you're preparing for IIT JEE, I guess Ananda, you're preparing for more like Olympiads and NTSC and those kind of examinations. That is very good. That is very good. Ananda Prabha, you should definitely prepare for all the Olympiads, but also do not forget, keep also grow your personality. If you're good in something, let's say arts, please make sure you nurture that. If you're good in, let's say, I don't know, creative writing, please nurture that. If you're good in let's say calculations, maths, make sure you make your maths really strong. If you like astronomy, then learn a lot of astronomy. If you're good with chemistry, make sure your chemistry becomes strong. So do that right now. I mean, Ananda Prabha, yeah, that's a very good time. Okay, thank you Bharni so much for all the love. Here is the next question which has come up on your screen. There is a convex lens of refractive index 3/2 and it has a power of 2.5 diopters in air. Now, if it is placed in a liquid of refractive index 2, then what is the new power? That's the question. Glad you love the morning sessions with Kapre. Good. Guys, we can have a separate discussion on which NIT is good, not good later on, but let's focus on the session. Yes, SG Vines, I do remember. Your Ashika, I remember you introduced yesterday's session. So good to see you back, and I hope I'll see you more often in all the live sessions. So Rupa, Tanuku, I mean, you can put up a comment in the comment section after the video is over. I'll definitely try and reply to all your comments, guys. Okay, come on, let's get going. Amin Mohammed, already I have mentioned this again and again. Please watch my recordings that, Wazim sir is not well, so that's why he's not coming. But as soon as he's out of the COVID situation, he will be joining us shortly. Okay, chalo, let's get going. Well, I'll tell you how to solve this question. Power for a lens is 1 by f, correct? And using lens maker formula, 1 by f is mu minus 1 by r1 minus 1 by r2, correct? That's what it is. But since it's a convex lens, all right, that means R1 and R2 magnitude wise will be equal, correct? Magnitude wise will be equal. And remember, by sign convention, what you're going to get is that the power is equal to mu minus 1, all right? Let's say R1, if it is plus R, R2 will be negative R because of the sign convention, that's it. And what you're going to get is 1 by R minus 1 by minus R. So that's going to make it 2 divided by R. Keep this in mind. So this is going to make it 2 divided by R. All right. Now, what we are going to do, we're going to use whatever is given. The power is 2.5 diopters. So 2.5 diopters where? In air. And what is the refractive index of that glass material? That's 3/2. It's given 3/2 minus 1 into 2 by R. Let's do this. What's going to happen next? 2.5 is actually 5/2. So 5/2 is equal to 3/2 minus 1. It's 1/2 into 2 by R. Keep this in mind. So I'm going to get 2 by R as 2 cancels. I'm going to get it as 5. Correct? So 2 by R is 5. Okay. I'll keep it aside. Next time when it is placed in a liquid, it is given. The only thing that will change is the power. So the new power will be the new refractive index, the relative refractive index minus 1, again 2 divided by R, the new refractive index. So now think about it. What is the relative refractive index? Glass kept in water. So it is the refractive index of the glass divided by refractive index of the liquid, which is 2. Refractive index of the liquid, which is 2. minus 1 and 2 divided by r, I just figured it out. 2 divided by r is 5. I just figured it out. 2 by r is 5. That will not change. So now 3 by 2 by 2 is 3 by 4. So 3 by 4 minus 1 into 5. That's going to be minus 5 by 4, which is negative 1.25 diopters. No, it's not option C. It is option A, negative. You forgot the negative sign. Now you might be wondering, sir, how can convex lens have negative power? It is possible. You'll be like, sir, negative power is diverging. Yes, but remember, lenses can change their power sign when you change the medium outside. Usually a convex lens is converging, but if you place it in a more denser medium, then it behaves like a diverging lens. The same is true for a concave lens. A concave lens is usually diverging with a negative power. But if you place it in a more denser medium, then it becomes converging lens. Keep this in mind. Okay, so very important concept that you are learning out here. So the answer is negative 1.25. Very good, Snehal. Very good, Shreyas. Okay, Sheetal. Let's get going to the next question. For a plano-convex lens, this is your plano-convex lens. Refractive index is given. Radius of curvature is also given. If it's silvered on its plane side, what is the focal length considering that it is silvered? What is their effective focal length? Think about it. What is the effective focal length? Come on guys, let's see how many of you can do this. It's very, very easy. Come on minions, this is a 30-second question. If you use a trick, there is a very small, nice trick in this question. If you use the trick, instantly you are going to get the answer. Instantly you're going to get the answer. This is very easy. Small trick is there. Come on minions, do this. Plane side is silver. It's a plano-convex lens. How R1 is equal to plus R? So see, the sign convention goes like this. Okay, this is our lens. This is positive. This is negative. Okay. So if this is my first surface, naturally this will be R1, correct? And this is my second surface. So naturally this will be R2, correct? So do you see R1, the center of curvature is on the positive side. That's why R1 is positive. And do you see R2's center of curvature is on the negative side. So that's why R2 is negative. I hope that is very, very clear now. Is it okay, Gayatri Arul? This is how the sign convention works. I hope I have answered your doubt. Okay, cool. Let's see how to solve this particular question now. You will need sign convention here too, I guess. Come on, minions. Come on, come on, come on. Some of you are saying A. I don't know. Some of you are saying B. Okay, well. The trick is, whenever you see a mirror, remember that you can always replicate whatever is there in the front behind the mirror of the same proportions. That's it. As simple as that. Whatever is there in the front, replicate it behind. Now what is there in the front? Plano-convex lens. So what should be there behind? Another plano-convex lens. Another plano-convex lens. Correct? So now you forget that there is a mirror. Just forget that there is a mirror. What does this look like? Forget that there is a mirror. What does this look like? Doesn't it look like a normal convex lens? A biconvex lens? Don't you see that instead of plano, it's like a biconvex lens. That's it. So that solves our problem. So forget the mirror and now use the lens maker formula. 1 by f is equal to mu minus 1 into 1 by R1 minus 1 by R2. That's it. Use this formula. Great. Let's see what will happen. Mu is 1.5 minus 1. R1, radius of curvature, well, that's 10. The second radius of curvature is minus 10. For obvious reasons which I explained before, this radius of curvature is 10 and remember this radius of curvature is minus 10. So that is R1. Okay, this is R1 and this is R2. Keep this in mind. Okay, so now this is going to be 1.5 minus 1 is 0.5, which is half. 1 by 10 plus 1 by 10, that's 2 by 10, correct? And that's 1 by f. 2 cancels, and therefore f is 10 centimeters, which is option A. That's the correct answer. Very good. Some of you got it. Very good, AVS. Very good, Laksh. Very good, Yalini. Very good, Snehal. Excellente, Chandrasekhar. Very good. So this is the trick. Whenever you have plane mirrors, you can replicate whatever is there in the front, behind. It simplifies the problem by a big deal. Keep this in mind. This is the trick for mirrors. That's the answer. Now, let's solve some questions on apparent depth and apparent height. A lot of people get confused, but there is a simple trick for that. Remember, if you are a fish, who are you? You are a fish. So you are a fish and you see a bird. You won't see the bird at the same place. You will see it more higher, more farther. Correct. Is this clear? That is called as the apparent shift. You will see the bird, if you are a fish, you will see the bird higher. But if you are a bird, so if you are a bird and you see the fish, you will see the fish closer to the water, more shallow, at less depth than the actual depth. That's how things work. That's how life is. Very good, Angry Jackson. Thank you very much. So keep this in mind. In life, the fish and the bird always get fooled. If the fish is going to get caught by the bird, the fish thinks, oh, the bird is very far. And the bird thinks, oh, the fish is very close. Both might miscalculate and it might be a puppet. Both of them might get fooled, but they know it by habit and by evolution that, if I see the fish over there, actually the fish is not there, it's much deeper. So the bird recalculates. And the fish also knows by its past experiences, all right? So, oh, if the bird is there, actually it's much higher, all right? So that's how things work. So the apparent height is mu times of the actual height. Keep this in mind. Apparent height is mu times actual height when you are a fish, and when you are a bird, the apparent height is mu times less, or 1 by mu times of the original height, all right, or original depth. Keep this in mind. Mu times, so mu is a number which is more than 1. So if you're a fish, multiply by mu. If you're a bird, divide by mu. Keep this in mind. If you're a bird, divide by mu, looking at a fish. And if you're a fish, looking at a bird, multiply by mu, whatever that actual height, you'll get the apparent height. So let's solve a problem based on this. Very good technique. A bubble is in a glass slab, but that bubble is not at the center, okay? When you see it from one side, that bubble appears at 5 centimeters. It appears at 5 centimeters depth. And from the other side, it appears at a depth of 2 centimeters. So what is the actual width of the slab? Come on guys, let's see how many of you can think about it. Come on guys. Come on. Come on. Good morning, Mutikudru Javavardhan. Yes, and we are humans and then we solve optics. Don't worry, even you are a very well-designed human being, very well-engineered human being by Mother Nature. So there are a lot of interesting things about the human body as well, which are very marvelous facts, very marvelous feats, I would say, of engineering designed by nature. All right, so let's do this. So when you see from one side the depth is 5 centimeters. So what will be the actual depth? Remember, 5 centimeters, or I'll just put it over here, because you are a bird. Remember, why are you a bird? Because you are in air. You are in air and looking at the bubble. That bubble is like that fish. Think of that bubble like a fish. Keep this in mind. Oh my God, is it like some country's flag or something? I remember there was a country whose flag just has a dot. Do you know which country that is? Okay, so you are a bird in air. So remember, the apparent depth is actual depth divided by mu. Use this formula and you're going to be sorted for life. So first thing, 5 centimeters is actual depth divided by mu. Mu is 1.5. So H1 is 1.5 times of 5. Keep this in mind. Next up, from the other side, Oh yes, very good Snehal, Shreyas, Vishal, very good. That's Japan, very good. And what are the colors? All right, what are the colors of the Japanese flag? So very, very simple flag. And from the other side, the depth is 2 centimeters. So 2 is equal to actual, I don't know, divided by mu, which is 1.5. So H2 is 2 times of 1.5. So from each side, the depth is H1 and from the other side it is H2. So the total width of the slab, is obviously H1 plus H2. So 1.5 into 5 plus 1.5 into 2. So that's going to be 1.5 into 7 or 3 by 2 into 7. 7 threes are 21. 21 by 2 is 10.5 centimeters. That's option C. Very good. Okay, so we have all the colors. No problem, guys. Just Google it later on. Okay, so 10.5 centimeters is the final answer. So you're learning a lot of physics and general knowledge as well. Very good, guys. So that's the answer. Is it clear? Shall we go ahead? Very good, Shreyas. Yes, the answer is C. Moving on. Next question. Beautiful question coming up on your screen. Let's see how many of you can do this. There is a fish which is going up to the surface in a lake at a rate of 4 meters per second. That's the velocity. 4 meters per second is the velocity of the fish. And it sees a bird. So for the fish, the bird appears to go down at 10 meters per second. 10 meters per second. That's what the fish sees the bird doing. If the refractive index is given, what is the actual velocity of the bird? Yes, actual h by mu only. No sir. Yes, sure, that is the apparent depth. And in the previous question, what was given to you was not the actual one, it was the apparent value. So the actual depth will be mu times of the apparent one. I hope that is clear. No problem, Vijay Kumar, join in. Hi Jaideep, welcome. Let's see how to solve this question. According to the given question, what is given to me is velocity of the bird with respect to the fish. And what is the velocity of the bird with respect to the fish? It is given to be 10, but it is going vertically towards the water. That means it will be minus 10. See if everybody has understood this. VBF, velocity of the bird with respect to the fish, is 10 meters per second downwards. Now what is the definition of V12 or V23, V5, 6, etc.? V12 is V1 minus V2, relative velocity. So this will be VB minus VF is the definition. Alright, this is minus 10. I hope this is clear. Therefore, this is just by definition. Therefore, VB minus, what is the velocity of the fish? It's already given, 4 meters per second. I hope you can see that. But where is it going? It's going vertically to the surface. It's going vertically, rising. So it's plus 4. So I hope this is clear. All right. This is plus 4 and that's what you're going to get. This is minus 10. So VB is going to be how much? Minus 10 plus 4, that's going to be minus 6 meters per second. All right. It's going to be minus 10 meters per second. Now, this is the image of the bird. This is the image velocity of the bird. Keep this in mind. The bird is actually going at some other speed. The apparent speed is 6 meters per second as seen by water. So guys, remember the formula. Apparent, actual. If you are a fish, if you are inside water, what happens? It gets multiplied mu times. I hope this is clear. I hope this is clear, guys. Check this out. So you have to use that particular logic to solve the problem. Keep this in mind, guys. So remember, apparent is actual multiplied by refractive index. That's what it is. That's when you are inside the denser medium looking at something which is in the rarer medium. Now the apparent velocity, the image velocity is already given to be 6. Actual, I don't know, multiplied by mu. Mu is 4 by 3. So therefore, the actual velocity will be 6 3s are 18, 18 by 4, which is 9 by 2, which is 4.5 meters per second. That should be option B. Beautiful question, isn't it? Beautiful question, isn't it? Is it clear, Vijay Kumar? Hello, Gayatri, Senthil. Very good, Ankit. Very good, Gayatri. Hi, Shabana. Welcome. Yes, that's how it is. Very good. So make sure you have understood this question. Beautiful question. A lot of confusing things. Many people are going to make a lot of mistakes in the signs here. They'll get confused. Acha, this is 4, this is 10. Will it be 14? Will it be 6? Will it be minus 6 plus 6? They'll get confused. But if you see, we have solved it very systematically. There is no room for error. And I just use the fact apparent is actual into mu. If you are a fish, remember, you are in water. You are in that water. So that's why you have used this formula. All right, let's get moving. And that's the answer, 4.5. Very good, Satyendra. Very good. Excellent, Yalini. Now let's see the last part today. Prisms. Get ready. Prisms. Let's talk about prism related formulas. All the important formulas of a prism. If incident ray falls at I1, refracts at R1, falls on the second surface at R2 and emerges out like this, the total deviation inside the prism is I1 plus I2 minus A. Okay, this should have been I1, guys. I don't know why I has come. This should have been I1 plus I2 minus A. Keep this in mind. This is the angle of deviation. Next, when you plot the graph of deviation versus the angle of incidence, the graph looks like this, and there is an angle for which the deviation, the ray which enters in, the deviation is the least. So when minimum deviation happens, then the conditions are I1 is I2. That means this angle and this angle are same. Even this angle and this angle are same. And this is the formula. Mu is sine of A plus delta by 2 divided by sine of A by 2. Keep this in mind. Yes. Marvels and Avengers. Where will NTA take their questions from? Well, they are going to take the questions from me, and they are going to take the questions from this series. They are going to call me up before the examination paper setting. They're going to call me up and they're going to like, okay, what all questions have you discussed? And I'm going to tell them these are the questions which I discussed, and you know, they're going to frame the questions accordingly. All right, so that's what is going to happen. Okay, cool. So yes, so Ankit, the thing is, see, if you have a prism and if the ray comes like this, it will come out like that. If the ray comes like this, maybe it goes like this. So every angle will produce some deviation. Now that deviation is the least when the situation is symmetric. When the angle of incidence and the emergence is the same, that is I1 is equal to I2, R1 is equal to R2. It happens at that particular angle. Okay, yes. Now this is for large prisms. All this is for large prisms. But when the prisms are small, sine of any angle will become the angle itself, and there are some approximations. So don't worry about it. Okay, well, we're just going to talk about it for now. This is the formula for large prisms and you should know it. Remember that. Okay, but for thin prisms, if you use the same formula, so the same formula, if you rearrange it, because sine and sine will go off for small angles, then if you rearrange it, then this is the formula that you get. Delta is A into mu minus 1. Keep this in mind. Yes, delta will be A into mu minus 1. That's only for thin prism. I have mentioned it very clearly. Keep this in mind. Okay, I hope, Ankit, now it's clear. All right, very good. And dispersive power. What is this dispersive power and all that, guys? I'll tell you what. Simple. See, guys, you have a prism. Okay, what will you pass? You will pass light. And what will happen? You will get enlightened. Yes, maybe, may not be, I don't know. So violet will be deflected the least, red will be deflected the least. So it will come out like that, and then blue will be deflected the most, or violet will be deflected the most. Now this is the mean color, actually yellow. So guys, I don't have yellow, this green is yellow. Okay, just assume that you are colorblind and this is yellow, so don't ask me why. Okay, this is red, yeah, you're not colorblind for red, and this is violet, this is blue, but this is violet. Okay, that's how things work. So I don't have colors, so you have to pretend that this is violet, you have to pretend that this is yellow, and you don't have to pretend here this is red, guys. Okay, please, if you're seeing this as something else, then you are actually colorblind. Okay, so guys, the thing is, when a white light enters and it spreads, the angle of spread, that angle of spread is that delta omega. Look at this, this delta omega is how much did it spread. This is the dispersion. This is the dispersion angle. Dispersion meaning how much is the spread. Now what do I mean by the spread? If you extend this line backwards and if you extend this line backwards, all right, so you can see that there is this whole angle out here. This angle out here is delta omega. I hope this is clear. The spread is called as delta omega. Yes, I hope this is clear. Okay, this is delta omega. The spread is called as delta omega. But dispersive power is how much is the spread on the top. How much is the spread per average spread? How much, or average deviation? Now this omega, all right, over here downstairs is, you know, the deviation of the average color. Who is the average color? Yellow, remember that? This yellow is the average color. It's exactly in between red and violet at the center line. So the average deviation of yellow is what this is. So that is called as dispersive power. Keep this in mind. Okay, so this is what dispersive power is, the spread upon the deviation of the yellow color. And using these formulas you can get it. All right, so the spread or the dispersion angle which is there in the numerator will be the deviation of violet minus deviation of red. Deviation of violet minus deviation of red will give me how much is the spread. Keep this in mind. So deviation of violet minus deviation of red, that remaining part will be delta omega, which is there on the top. Keep this in mind. Okay, that's how this works. Is that now clear, guys? Everyone understanding all the different terms which you would have seen in prisms? So this is what it all means. Okay, clear, 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 not clear, not clear, not clear, not clear, not clear. Let me know, let me know, let me know. Everyone done, done. Shall we go ahead? Okay, chalo, let's go ahead. And the last two things, dispersion without deviation, deviation without dispersion. Guys, just concentrate on that word which is not happening. So for these two cases, my logic is this: dispersion without deviation. Check what is not happening without deviation, without dispersion. Now when I say there is no deviation, understand what is happening. The light which is entering through first prism and then through second prism on an average is not deviating. Like if the rays were coming in this direction, first prism, second prism, it comes out, the rays which finally come out and the rays which are initially coming in almost are parallel to each other. So what you're going to do, check the average color. Who is average? Yellow. The average yellow color deviates and counter deviates and becomes parallel. The average yellow color, this is, oh my god, this is red. Where is our yellow? So this is yellow, right? I hope somebody is not watching this lecture from now and they will be like, what the hell is Sir teaching? This is yellow. Okay, so this is yellow color, guys. It deviates and deviates back. This is from the first prism, second prism. And it eventually comes parallel then this is dispersion without deviation. That's why you see deviation in the first prism is deviation magnitude wise. This is all magnitude wise in the second prism. So that's why it becomes parallel. Is that clear? Yes, deviation in the first prism magnitude wise is deviation in the second prism. That's the condition for that. Similarly, for the next part, so that's what has been shown over here. Similarly, for the next part, if there is no dispersion, now dispersion means spread. Remember, dispersion is nothing but spread. This is the spread. Yeah. The light spreads in the first prism and again converges back. So there is no spreading of light. There is no spreading of light. So that's why I have equated the spreads of the two prisms. Remember, delta omega was the spread. So light spreads in the first prism and light again spreads by the same amount, but in the opposite way, because the other prism is opposite, it's upside down. So if the prism is like this, it spreads. If the prism is upside down, then it again converges back. So that spread becomes the convergence. So the spreads of both the prisms are the same. So whatever light spreads again comes back and forms white light. I hope this is clear. Alright, so that's why you equate the two. So always concentrate on what is not happening, not on what is happening. This is without dispersion. So no dispersion should happen. So whatever the spread is countered back without deviation. So whatever deviation happened with yellow is countered back by the second prism. That's what it is. Let's check out some problems. Very good Sheetal, very good Shabana, very good Yalni, very good Jagdish, Shreyas, Sri Krishna. Hello Avinash Kulkarni, welcome. Amish, it seems that I just woke up. My God, I have been teaching for the last 1.5 hours almost, and I woke up 1 hour before that. I had my breakfast too. Yes, I had my breakfast too before 7, and I'm all, pumped up. Hello Dhiman Sab. My God, what a name. Good morning. Good morning Sab. Good morning Sab. All right. So prism having some angle over here, light is falling like this, it gets deviated, it hits the mirror and it goes back. So what is the angle of deviation from the mirror? What is the angle of deviation from the mirror? Come on guys, let's see how many of you are going to get this. Come on, this is a 20-second question. You should have got this by now. Sanjarani, I didn't upload yesterday's lecture. YouTube will automatically do it. YouTube will automatically do it. Remember that. I don't have to do anything. It's already there. Check out the past videos. Please check out the playlist. It's already there. Okay. So guys, it's very simple. Remember, in a prism, for a prism, what's the deviation? Delta is A into mu minus 1. Use this. What is A? 4. What is mu? 1.5 minus 1. 1.5 minus 1, it's 0.5. 4 into 0.5, that's 2 degrees. Correct? So the light deviates by 2 degrees. It hits the mirror. So if it deviates by 2 degrees, think about it. If it deviates by 2 degrees, the angle of incidence is also 2 degrees. Correct? The angle of incidence is also 2 degrees. I hope this is clear. And then the light is going to get reflected from this. This is the reflected light. So what is the deviation from the mirror? Remember, there is a formula 180 minus 2i. I hope this is clear, guys. 180 minus 2i. Everybody understanding this? Yes. Yes. Very good. So what will be the answer? 180 minus 2 times of 2. How much is it going to be? 176 degrees, which is option A. Is that clear, guys? Yes, option A is correct. Very good. Let's get going. Oops, what the hell happened? Yeah, that's the correct answer. Very good, very good. Yes. Now, let's go to the next question. If the wavelength of light is increased, then minimum deviation, refractive index and frequency, what will happen to that? Come on, think about it. All of them, what will happen? If the wavelength of light is increased, if the wavelength of light is increased, delta m, refractive index and frequency, what will happen to all the three quantities? Come on, think about it. Think. Very interesting question, guys. Let's see how many of you can do this. Beautiful question. You need to know a lot of theory for this, believe me. Come on, guys, let's do this. Come on, minions. Think. What will happen to all of them if the wavelength of the light is more? Very good. Let's see what the answer should be. I don't know. People are saying A, is it? Okay, let's have a look. First of all, frequency into wavelength is speed of light. So if wavelength is increased, clearly it's mentioned, wavelength increases, obviously the frequency of the light should decrease. So hence the frequency which is mentioned over here, that should decrease. Done. Next, we have seen that in a prism, all right, the violet light deflects the most, correct, and the red light which is there, it deflects the least. We have seen that. So who has more wavelength? Obviously red has more wavelength and violet has shorter wavelength. Remember that? So think about it. Deviation wise, who has more deviation? The one which has more wavelength or the one which has less wavelength? So think about it. Red has more wavelength, so it also has less deviation. So if lambda is more, delta is less. I hope you see that. Red has more wavelength, the deviation is less. I hope you see that. And we are talking about refractive index. Well, since the deviation is less, that means the refractive index is also less. So naturally, mu is also less. Think about it. Red has large wavelength, it did not deflect so much, so refractive index is less. Violet has small wavelength, it deflected large, that means refractive index for bending is also more. So hence, all of them will decrease. Keep this in mind. Very good. Sandhya Rani, electrostatics, I think so, yes. On 0 to hero series, yes, I have completed electrostatics. So if you have missed it, my request is please watch the playlist. All right. So in fact, guys, if I show you, all right, the playlist is right over here. Okay, just watch the playlist, guys. All the playlists, whatever is required for all of you is over here. All right, in the playlist section, just go to physics and you can see out here. Okay, 0 to hero physics playlist is there. 0 to hero physics playlist. Okay, so you can scroll through this. Center of mass, communication, collisions, rotations, semiconductors, electrostatics, gravitation, magnetism, units and dimensions, kinematics, Newton's laws, circular motion, optics, and all of that is there. And if you want in detail lectures, then you have this flash series. So this is flash series, all the lectures in little bit more detail. All right. So SHM, thermal physics, fluid mechanics, mechanical properties, everything. Somebody wanted mechanical properties. So there we go. It's all there. So mechanical properties, all 4 lectures on mechanical properties, guys. So that's how it is. So guys, yeah, I think that's it for today then. All right. Yes, definitely, Mayank. We are going to do short questions for April attempt as well. Definitely. Very good, Snehal. You got all +4s today. Very good. Yes. Okay. Chalo. So all those of you who want to join the crash course and all those of you who want to complete the syllabus in the next few weeks and who want to boost their performance, guys, Vedantu is also offering a crash course, and the link for joining the crash course is there in the description box below. So please check it out, because there is an English batch and there is a Hindi batch separate. Plus your doubts will be answered in the class and even after the class. And also you can watch the replays of all the live classes. The classes are all live. You can interact with the teacher. There are quizzes, there are polls, there are hotspots, leaderboards, everything. Plus you can watch it as a revision n number of times, and there will be 15 full syllabus tests and 5 part syllabus tests which will be conducted in this crash course. So you get test series as a part of the crash course itself, plus you get assignments, notes, handwritten ones as a part of the crash course. And remember, this crash course, all right, is going to definitely boost your performance in the upcoming JEE Mains examination. So please check it out. So if you are not satisfied with your coaching, if you are not happy with your coaching, and if you want teachers like me to teach you, then guys, please join the crash course, because you are getting 40% off on the crash course, which usually costs 10,000 bucks. Now you get it for 6,000 bucks after you use the coupon code SHCC. So use this coupon code, and if any problem happens during enrollment, etc., when you use this coupon code, I'll be able to help you out. So please use this coupon code, join the crash course, do not delay it, because the examination is hardly few weeks away. And if you have enjoyed the session, please do not forget, you can download the PDF by joining our Telegram group. All the important announcements, etc., are made on our Telegram channel. So this is our channel link, which is also there in the description box below. And please do not forget to give us a like, because it means a lot. And also do not forget to hit the subscribe button if you're a new user for this channel. So tonight I'm going to see you again in the second lecture of Pathfinder series, Forces and Field. Bye bye, take care, see you.